Hi, now let's try this question. This question is from your Form 5 Math, Chapter 8, Kinematics of Linear Motion, and is taken from SPM 2022. Diagram 7 shows two particles, A and B, move along a straight line. At instant t equals 0, particle A and particle B move off from point M and point N respectively. The displacement s meter from point M for particle A and particle B is given by these two displacement functions. So be careful. The reference point for these two displacement function is point M. Okay, let's say if you get SA is equal to 5. This means that 5 meters from point M on the right hand side. Positive, right? The same thing if you get SB is equal to let's say 20. What does it mean? It means 20 meters from point M, not from point N. Point M is the reference point for these two displacement function. Okay, now let's look at the first part. Find the initial velocity in meter per second of the particle A and particle B. So we want to find the initial velocity, means that we need a velocity function, right? So how do we get the velocity function? We differentiate the displacement function. Before we solve the part A, now if I ask you what is the distance between the point M and point N, how do we know the distance between point M and point N? We can just by looking at the two given displacement function, we actually know that the distance here is 18 meters. How do I know 18 meters? Now, when t is equal to 0, means that when the particle is going to start, you will get 18, right? Why we get 18? Because this is the point M is 18 meters on the right hand side of point N. From point M. So the B is 18 meters from point M at the beginning. Okay, now this is a displacement function. Now we want to find the initial velocity. We need the velocity function. So velocity function is equal to ds dt, right? So differentiate this function. Bring down the 3 and don't forget the power. You have to minus 1. 2 times 4, 8. Power minus 1, 2 minus 1, you will get 1. Differentiate 5t, you will get 5. Okay, so this is the velocity function for initial velocity. T is equal to 0, right? When t is equal to 0. Three times 0 square plus 8 times 0 plus 5. So we will get 5. So from here, we know that the initial velocity for particle A is equal to 5 meters per second. Okay, now let's do the same thing for particle B. Differentiate this one. 3t squared minus 2t plus 4. Okay, so same thing when t is equal to 0. Actually, you know, right? When t is equal to 0 is actually equal to 4. But I still show you how to get the 4. So velocity for B is equal to 3 times 0 square minus 2 times 0 plus 4. So the velocity is equal to 4 meters per second. Initial velocity for particle B is 4 meters per second. Okay, now let's look at part B. Find the distance in meter traveled by the particle A and particle B at the instant they collide. So first, I need to know when the two particles collide each other. Okay, when they meet each other, SA will be equal to SB, right? They will have the same displacement. Okay, t cubed plus 4t squared plus 5t is equal to t cubed minus t squared plus 4t plus 18. So both sides we have t cubed, we can just cancel out this t cubed. Okay, now 4t squared plus 5t plus t squared minus 4t minus 18 is equal to 0. I bring all this term go to the left hand side. Okay, now let me continue simplifying it. Now we can start to do the factorization. You can use your calculator to help you. This one 5t t. So this is plus, this is minus. Okay, so 5t minus 9 is equal to 0, or t plus 2 is equal to 0. So t is equal to negative 2. This one not accepted because the t, right, times cannot be negative. Not accepted. The t over here is 9 over 5. So 9 over 5 we also can write in a in decimal, which is 1.8. Okay, now we know when t is equal to 1.8, they collide, they meet each other. So I want to know the distance traveled by particle A and particle B at that particular moment. Okay, can I directly substitute the t equal to 1.8 into this displacement function to get the total distance traveled? First, I need to know when the particle turn direction, right? Still remember? Let's say if this is a displacement graph, let's say this is tray. This one I told before, right, in the previous video. If I want you to find the total distance travel for the first 2 seconds, so in this situation, what you need to do is to substitute the 2 inside the displacement function. You get the answer. This is a total distance travel. So how about if I want to find the total distance travel for the first 4 seconds? If you just substitute the 4 inside the displacement function, you get this value. You say this value is a total distance travel. It's just not correct. The total distance travel should be this distance plus this distance. So you need to be more careful. So how do we know when the particles start to turn direction? Turn direction, v is equal to 0, right? So I'm going to use my calculator to help me to know when the particles start to turn direction. So just press your calculator. Three, 8, and 5. Okay, you will get negative 1 and negative 5 over 3. Negative 5 over 3. Okay, negative 1.6. I just round off with two decimal places. Negative 1.67. Negative 1 and negative 1.67. So, but the question does not request you to sketch a graph. The sketching graph here is only to help us to know when the particles start to turn direction. Okay, this is 5, and this is negative 1.67. This is negative 1. So but we are not interested on the left hand side, which is t equal to negative value, because t cannot be negative value, right? So we know that the particle will not turn direction. Okay, let me show you. Let me sketch this graph for you. Now let's look at this graph. This is the velocity function, and this is the displacement function. Okay, this is a graph we got just now, negative 1 and negative 1.67. Okay, now let's look at this graph. For the green color one, this is displacement function. Now this is as what we expected just now. The particle does not turn direction. You see, it just keep on going to the right. It will not turn back. So therefore, to get the total distance travel for the first 1.8 seconds, what we can do, we just substitute the 1.8 into the displacement function, and we will be able to get the total distance travel. Okay, distance travel, this is for particle A when t is equal to 1.8. 1.8 cube plus 4 times 1.8 square plus 5 times 1.8. Okay, just press your calculator. 1.8 power 3 plus 4 times 1.8 square plus 5 times 1.8. Okay, it's equal to 27.792 meter. Okay, now let's go. Let's try find the distance for particle B. Okay, so if you press your calculator for this one, what we did just now, we want to find where the particles start to turn back. You try to see when you press your calculator, 3, -2, 4. You will get a complex number, right? This means no real root. So means that this graph will not touch the horizontal axis. So from here we know that this particle will not turn back as well. So let me sketch a graph for you. Okay, now look at the velocity function. You see the graph will not touch the horizontal axis, and we know that the particle will not turn back. You see this, look at the green color one. The green color graph is the displacement function. The particle will just keep going to the right, will not turn back. Okay, but you need to be more careful when you want to find the distance travel for particle B. So here I don't have to, I can get the distance travel faster for particle B. What I need to do is, I know that the particle B is actually 18 meter on the right hand side of point M, right? So when they collide, when they meet each other, try to think, when they meet each other, for example here, the distance traveled by the particle, okay, let me write bigger, particle A, particle B. Let's say they meet each other here, they collide here. So you will notice that the distance traveled by particle A and particle B are not the same, right? The distance traveled by the particle B is actually 18 meter less than particle A, right? To get the distance traveled by particle B, what do we need to do is distance travel. We just take the distance traveled by particle A, 27.792 minus 18. Okay, 9.792 meter. Now, let's go to the last part. Calculate the acceleration in meter per second square for the particle A and particle B immediately before the collisions occur. So we know that they collide when t is equal to 1.8, right? So we want to find the acceleration when t is equal to 1.8. So how do we get the acceleration function? We differentiate the velocity function, right? Okay, this is the velocity function. So if I want to find the acceleration function for particle A, I differentiate the velocity functions. So 2 times 3, you will get 6t plus 8. Okay, this is the acceleration function for particle A. Now let's do the same thing for particle B. The acceleration function for particle B. Differentiate the velocity function. 2 times 3, 6t minus 2. Okay, when t is equal to 1.8. So acceleration for particle A is equal to 6 times 1.8 plus 8. Okay, is equal to 18.8 meter per second square. Now let's do the same thing for particle B. When t is equal to 1.8. So the acceleration for particle B will be equal to 6 times 1.8 minus 2. K is equal to 8.8. Okay, that's all for this video. See you in the next video. Bye bye.